Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to finish up section 5.2 by learning a little bit more about quadratic functions. Anytime you take a quadratic function, remember that means that your x has a power of 2. Anytime you substitute any real number or any real value into x, and if you went ahead and calculated that in the calculator, you would end up with a real number. Because of that statement, the domain of any quadratic function is the set of all real numbers. And what that tells us is, let's say I'm trying to graph a quadratic by making an XY table. There are no limitations as to what I could put in that table to try to find the Y value. Every X value that's real would produce a real Y value. So the main thing is you need to know that the domain of any quadratic function is all real numbers. Okay, the range are your Y values. Now the range depends on the vertex and the direction that the parabola opens. If the parabola is opening upwards, notice the Y values increase. If the parabola opens downwards, the Y values decrease. So here you would be saying y is greater than or equal to. Here it would be y is less than or equal to. So it does really depend on the direction that the parabola opens. If it's up, it's greater than or equal to. If it's down, it's less than or equal to. Okay, remember, domain means the x's, range means the y's. To find the range, you start with the y value of the vertex. So remember, every vertex is an ordered pair. They are calling it HK if you look at the vertex form of the quadratic. So it's always going to be whatever the y value from the vertex is, because that is either going to be the highest point or the lowest point. Because remember, your vertex is either your maximum or your minimum. So it's kind of cool. One more thing that you can do with that vertex ordered pair, you can identify the range. So here are just some little helpful hints as we go through this. If your parabola opens upwards, your vertex is a minimum. Your domain is always all real numbers, okay? So you can write it, or you can write that funky symbol. Because it's opening upwards, y for the range is greater than or equal to whatever the y value is from the vertex. Okay, so range is the y value. That's why we're focused on the y value. If your parabola, if your parabola opens downwards, then your vertex is a maximum point. Your domain is always all reals. Okay, it does not matter. Every single quadratic is going to have a domain of all reals. Your range, because it's opening downwards, y is less than or equal to, again, it's the y value from the vertex. Okay, so this slide is kind of like your little cheat sheet for what we are doing today. Okay, let's go ahead and work through a couple problems together. Here is my function, okay? So the function is negative 16x squared plus 32x plus 4. They want us to find the minimum or maximum value, then state the domain and range. So determine if we have a minimum or a maximum. We have to see if this graph will open up or down. Remember, that's based off of A. A is the number in front of the squared term. So A is a value of negative 16. Because A has a negative value, the parabola is opening downwards. If the parabola is opening downwards, your center point is a maximum. That is the first thing that you will be answering on every question, okay? It is the vertex a maximum or a minimum? To figure that out, you have to see if the graph opens up or down. You always check that value of A. Now to find the x value for the vertex, because remember, the vertex is what's going to help us as we go further. To find the x value, it's the opposite of b over 2 times a, all right? So b is the number in front of x. It's a positive 32. I do the opposite of b, so it's negative 32. Then it's 2 times a. A is the number in front of x squared. 2 times negative 16 is negative 32. Negative 32 divided by negative 32 is a positive 1. That's the x value for the vertex. To find the y value, we go up to the original function, and wherever there's an x, we have to fill in that x value. We fill in the 1. So if I have negative 16, 1 squared, plus 32 times 1 plus 4, this would be 20. That's your vertex. So if I'm looking at this, and I'm just kind of sketching, so 1 and 20, the parabola's opening downwards, this is the highest point. Okay, that's what they're telling us, okay? So 20 is the maximum value. It occurs 1 unit to the right of the y-axis. Okay, using the x value, find the y value of the vertex. Check, we did that. State the domain. The domain of every single quadratic is the same. It is all real numbers. The range, the parabola is opening downwards, so its y is less than or equal to the y value from the vertex. Then it says that we can go ahead and check our answer by graphing on the graphing calculator. So I'll do a couple of these on Desmos just to kind of show you what that means. So if I have negative 16x squared plus 32x plus 4. Again, what we can do with Desmos is we can go ahead. Number 1, we said that the graph should be opening downwards. Yes, it's opening downwards. If we go ahead and tap that highest point, which you can tell is the maximum, it is the highest point, it should be at 120 or 1 and 20. That is exactly what we have here. So it's just one way to check and make sure that our work is correct. Okay, let's do another one. Here is the function, x squared minus 6x plus 3. Step 1, determine if you have a maximum or a minimum. To know that, you have to know which direction your graph opens. So that's based off of A. A is an unwritten 1. 1 is a positive number, so the parabola opens upwards. If the parabola opens upwards, the vertex, the center point, it's at the bottom. So it's a minimum. That is the first point, okay? Then we want to find the x value of the vertex. Remember, the x value is the opposite of b over 2 times a, okay? If I look at this, b is a negative 6. That's the value in front of x. Negative, or the opposite of a negative 6, is a positive 6. 2 times a. A is an unwritten 1. 2 times 1 is 2. So x equals 3. Using the x value, find the y value of the vertex. So what you do is go back to the original. Wherever there's an x, you plug in that 3, because that's what the x value is. So I have 3 squared minus 6 times 3 plus 3. My y value is negative 6. So if I'm just going ahead and sketching this, I have a parabola opening upwards. This center point, it's a minimum. It is located at 3, negative 6. Your domain 100% of the time is all real numbers. That will never change with quadratics. Your range represents y's. Because the parabola is opening upwards, y is greater than or equal to the y value from the vertex, negative 6. Then we can go ahead and check it just to make sure that we're on the right track. Okay, one cool thing with Desmos, let's go ahead and get rid of that. Notice that I kind of had zoomed in. This home screen, or this little home key you can see right there, when you click that, it goes back to like a standard screen so you can see all 4 quadrants. Let's enter the new quadratic. It's x squared minus 6x plus 3. Here is what I have. We said that it should open upwards, giving us a minimum. It does. We said that our vertex should be located at 3, negative 6. It is. Okay, so we double checked. Everything looks good. Let's do one more together. Find the minimum or maximum of this. Okay. So here is my function. Notice it doesn't have an x. That means it's the same thing as negative 2x squared plus 0x minus 4. Because if you're trying to find your value for a, b, and c, you need to remember that a has to be in front of an x squared. B has to be in front of x. So notice that there's not an x here. That's the same thing as 0x, so B has a value of 0 in this problem. C is your constant at the end, and in this case, it's a -4. So step 1, determine if the function has a maximum or a minimum. That is based off of A. A is the number in front of x squared. It's -2. Because A has a negative value, the parabola opens downwards. If the parabola opens downwards, its center point is at the top, meaning this graph has a maximum. Okay, and as you go through your assignment, I'm having you follow these directions, not what the book says. So you're doing 8, 9, and 10, and then 24 to 29. Every question, A, maximum or minimum. That's what this is, okay? B, find the x value of the vertex. So it's right in order of this, A, B, C, D, okay? So B, x equals the opposite of B over 2 times A. So x equals the opposite of B. B in this case is a 0. There's no such thing as a -0, okay? So the opposite of 0 is still 0 over 2 times A. 2 times a -2 is a -4. 0 divided by anything is a 0. So 0 divided by -4 is 0. That's what part B is. Find the x value. So the opposite of B over 2 times A. Then find the y value. So the x value is a 0. To find the y value, you go back to the original, and wherever there's an x, I have to plug in the x value, which is a 0. 0 squared is 0. 0 times -2 is 0. 0 minus 4 is -4. So now I have the vertex. So what I have here, because I'm a visual learner, I need to sketch it. I have a parabola that's opening downwards. Its maximum point is located at 0, -4. Your domain is all real numbers. You can either write all real numbers or this funky little symbol that means all real numbers. Your range is always y. Look at the direction the parabola is opening. It's opening down, so it's less than or equal to the y value from the vertex. That is it. So as you do the assignment again, do not follow the directions in the book. So hopefully you did this whole video, otherwise you might get a little confused, okay? So you're going 8 to 10, 24 to 39. You'll find those questions on page 328 in the textbook. For each one, A, does this parabola have a maximum or a minimum? B, use x equals the opposite of B over 2 times A to find the x value. C, use that x value to plug it in and find the y value of the vertex so that way you have the full ordered pair. D, domain and range, and that is it for the day. Hope you guys enjoyed finishing up 5.2, and I'll talk to you soon.